All right, welcome everyone here in person. Welcome everyone online to another Jackson Systems training, a live training experience that we are bringing to you free of charge. How great is that, Eric?
That's awesome.
It is awesome.
Can't beat that with a stick.
Exactly. So Eric, what in the heck are you talking about today? Because one thing that we don't talk about enough at Jackson is refrigerant.
Okay, so today we're going to talk about refrigerant recovery. So getting the refrigerant out of the refrigerant system, your air conditioner, refrigeration system, whatever, into a recovery tank in a timely manner. And then we're also going to talk about evacuation, which is pulling things out of the refrigerant system before we put the refrigerant back in to make it run properly.
Yeah, and we talked about this earlier, but usually when I heard evacuation recovery, I was thinking about my college days.
We don't want to hear about those.
Yeah, exactly. No, but some housekeeping things real quick. This is a live training, so this is meant to be interactive. The more questions, the better. We will answer, especially here live. If you guys say, have a question, either raise your hand or just chime in, and we'll get to that in a timely manner. And especially for everyone watching online, we will get to your questions. So please feel free to use that chat box there. You can submit your questions. Also, you can see his slide presentation, tons of information there. And we can get this live interactive training going online. And,
bring on the questions.
Absolutely. I mean, that makes the training better.
Exactly.
If there's interaction like that.
That's what we're here for, is to help people out.
Absolutely. The Jackson way. So, Eric, I'll go ahead and let you take care of the rest of this training. And again, if you guys have any questions, please chime in. Take it away, Eric.
Thanks, JD. Have fun. All right, folks. Thank you very much for having me in tonight, Jackson Systems. My name is Eric Kaiser, and I work for ETS Group. In the local area here, I represent the Appion products. So tonight we're going to be using a lot of their products. A lot of the things we're going to talk about work with a lot of different products. So, use what you have. If you need to get something else, we got a lot of good ideas and a lot of good products for you to be able to use. Now, without further ado, let's kind of get on to the program here tonight. I come from the field a lot. Just to give you an idea about my background, I spent about 11 years in the field. I've worked for a distributor as technical support and training. So I've got a varied experience. I've done a fair bit of things, but there's no way that I've done everything. So, if you guys have questions or want to ask about something, I can probably answer it, or I may know somebody that can answer the questions if I can't find it. Anyways. Let's move on to the next piece. We're going to talk about several different things tonight. We're going to talk about some connection techniques. We're going to talk about things like hose selection, how to make connections up to the system, things like that. And here we go. There we go. Now we're moving stuff along. So we want to talk about speeding up the evacuation recovery process, getting it done in a timely fashion, maybe get us to go home on time at night if we have to, something like that, because sometimes recovery or evacuation can take a while, and we want to make sure that gets done in a timely fashion, as well as getting it done properly for the longevity of the system, which is another benefit to your customer. Anyways, so really, this is geared towards people that have a little bit of experience in the field. You know how to do recovery and evacuation, because we're going to take it to the next step. We're going to talk about speeding it up, increasing the speed, getting stuff done faster, right? So let's talk about the first step in this. When we are doing recovery or evacuation, we're moving a fluid, whether it be a gas or a liquid state. We're moving a fluid from point A to point B. Now, in order to move fluids, we need what? Now, I want to ask you guys here in the room, what do we need to move fluids? Differential pressure, right? So, in order to move a fluid faster, we can either increase the differential pressure, or what's the other thing we can do to move a fluid faster? Right, increase the size or decrease restriction is what I like to say. We need to remove restrictions. Okay, so we need to take the restrictions out of our flow path. One of the biggest restrictions is inside our connection point to a system. Now, if we can zoom in on that so you folks online can see this a little bit better. This is a cutaway of a valve core. Okay, so I'll pass this around the room, and folks online can be able to see that as well. And what we're looking at inside of here is actually how much we open this valve stem when we press this in, okay? And we're not opening it very far. It's a great way to access it to take a pressure reading, but it's not real good for moving a high volume through it. It's a very good restriction in there. It actually acts as a metering device if we go to start putting liquid, things like that through it. And we have our first question, yes, from online.
From my guy Lee down in the great state of Tennessee at AirServe. He wants to know, he just tuned in, did you talk about what equipment you're going to be going over? Is there a specific equipment line that you're going over?
So I represent the Appion product, which is what I will be demonstrating tonight, yes. Thank you very much. Now, in this, the difference between these two, the top one, of course, is closed, and the bottom one is how far we press this pin open. And you can see me cycling that through right there. This is how far we press it open when we're using a hose with a depressor on it. It's not real far. It's greater than a 90% area restriction inside that point. So I'll pass this around and let the folks here in the room be able to see that, take a look at that. Now, in order to remove that core, we use what's called a core tool, okay? So we're going to screw that out. Now you can see that pulling the core out. This one's a little damaged. And we pull that core out of there using a core tool. And that core tool then gives us a valve that we can manually operate, but it gives us a straight through flow path. So this is the first step to really removing restrictions both for recovery and for evacuation, okay? So you can pass that around. You can see the real easy, the large amount of flow through the middle of that as we're going. Now, when we use these of course are going to go on our ports on our system. I've got some simulated ports here that we will use tonight. So you would put this on a system port. It's important to realize that under normal operation, you're going to have high pressure inside of this, okay? So when you push this in, you want to find it, you want to index it, you want to make sure that it's seated tight onto that core. Keep pressure in on the back of this, and then unscrew it with your other hand. Because otherwise, as soon as you crack that with one hand, it's going to pop that stem out real fast, and you're going to lose the core in there, and then you got to go back in and find it. Turn this until it clicks. You'll hear a faint click, and that's your last thread, and then close the valve, and then you can remove the stem. And of course, this one didn't grab onto it quite tight enough. I did not get it seated good enough. Sometimes this happens. You don't get it seated onto the stem every time, and it doesn't grab it and pull it out. You have to actually go back in and find it. Sometimes it takes a minute to do that. One of the pieces on any core tool that I've used is it's very easy to over tighten them. Sometimes you actually have to loosen it about a quarter turn, because what happens is there's an O-ring inside that fitting that's a round O-ring. And if we over tighten them, which is our habit as technicians, because tighter is better, okay? And this is our mentality. So,
hey Eric, can you rotate that a little bit, like 90 degrees towards the camera? And do that
this way?
Yeah.
Okay, yeah. That way everybody at home can see it too? Yeah. Is that better? Perfect. Thank you. So as we're loosening this, okay, and it never fails. As soon as I get on live TV, something's not going to work right? Okay, there we go. So that's how to use a core tool to pull the core out. Now we have a manually operated valve on here that we can open and close. Of course, there's no pressure in this system, but we can open and close that as necessary. We also have a side port available on the core tool. Now that side port is always going to be accessed onto the system whether or not this valve is open or closed. Okay, so this is where we want to make our connection back here for recovery, for evacuation on the back side. This is an auxiliary port. We'll talk about how to use it later. Talk about a couple different configurations. On a normal system, smaller systems, you're going to have at least 2 ports on there. Some mini splits you're going to find have a single port on them. And when you get into larger systems, you're going to have multiple ports at different types of, different places throughout the system. You really need to know how many core tools you're going to have because you want to have one for every port. And even I use these on ports on larger systems, things that like a king valve, things like that, or service valve that are manually operated. I will still even put these on there and then put my caps back onto those valves so that I don't have any leakage around the packing stem. Now, if you guys understand what I'm talking about, you've got a manually operated valve you're using a refrigeration ratchet on. You can get leaks around that packing stem, especially under a vacuum. So it's a good idea. Set those in a position, put that cap on, and then use this as your access valve on there because these are a vacuum rated tool. Now you need to make sure whatever valve core tool you've got, it's vacuum rated, right? Because there are a lot out there that are not. They're great for removing valve cores and replacing the valve cores, but they don't work well under a vacuum and they'll cause you to have problems. Believe me, I know, I own a lot of them. I bought a lot in my quest for actually finding a way to get a good vacuum. So, we've got two connections on the system. You walk up to a system, you're going to do the work on the system. I use this as my first on, last off tool. If I'm pulling refrigerant out, if I'm doing evacuation, these are my first on, last off because I want to be able to move things through those connections quickly. Now, let's talk about a little bit more. So that's our first step on removing some restrictions. Some other restrictions we'll talk about as we go along when we talk about hose selection and things like that. Okay, so we'll talk about that as we go. Now, let's look at liquid versus vapor recovery. So, of course, liquid has a higher density than vapor, right? By quite a bit. When we're recovering things, we can pull liquid, we can pull vapor, we can pull a mix out of a system. Ultimately, we want to put it into a recovery tank. Now, when we put it into a recovery tank, what are we filling that? What do we need to fill that tank with ultimately? Liquid, right? We want this to be 80% full by volume of liquid. No more than that for safety reasons. So, when you're talking about putting liquid in here, we need to find liquid in the system. We need to get liquid out of the system, and we need to keep it liquid as it goes through the machine, okay, and then liquid into the tank. Does that make sense to everybody? Okay, so that's one reason why we pull these restrictions out, so that we can put liquid into there. If at all possible, we want to pull the liquid out first, fill the tank with liquid, because what happens when we're talking about the liquid going into the tank, if we put vapor in this tank, what do we have to do after that vapor's in this tank? Condense it. Does this tank make a good condenser? Terrible. Absolutely terrible condenser. It's not designed to be one. So, if we can put it in liquid in that tank, we get our tank filled quicker, and we don't have to dissipate all that heat out of there. So we can get the tank filled without dissipating the heat. Make sense? Okay. Now, let's talk about some recovery tank safety. On your recovery tank, you're going to find two numbers that we really need to know about for weight numbers. What are those numbers that we use on that tank? Tare weight, TW. And then the WC. What's WC stand for? Water capacity. And that means that if we were to liquid fill this tank 100% with water, that's how much weight we would put in that. All right, so that tells us the internal capacity of the tank. Tare weight, of course, is the capacity of, or the weight of the vessel itself when it's empty or full, it doesn't matter, but it's the weight of the material of the vessel. Okay, so you have to add those two together, and then you would get the total weight of that tank if it were liquid full with water. Here comes the rub with this, okay? Water and refrigerant don't weigh the same by volume. Now that's what this handout, you folks online can get this through the link, or this handout for you folks here in the room talks about. This shows you the difference between water weight and refrigerant weight. And it gives you a mathematical calculation about how to use that to be able to fill your tanks properly and not overfill them. In some cases, when I was taught, I might have been underfilling tanks, and in a lot of cases I was overfilling tanks. Because some refrigerants weigh more than water does by volume, and some weigh less. So if we have a cubic foot of water, some refrigerants, if you have a cubic foot, is going to be lighter. If you have a cubic foot of refrigerant of another type, it may be heavier than that same cubic foot of water. That makes sense? Yes, sir.
I'm very ignorant, so pardon me. Is there a scale or a computer that does all this for you on the fly so you don't have to do all the math? Or
Yes. Okay, so is there a scale or some kind of a device that will do all this math for you? Not at this time that I know of. Okay? It is fairly simple math. Now you do need to have a scale underneath your tank while you're filling your tank. Okay, that's part of safety, because if you don't have a scale under there, you don't know how much refrigerant you're putting into that tank, and you can overfill your tank real fast. And if you've ever seen a tank release, it's not pretty. Okay? Now, do we have any questions about the math or anything on that sheet? How to use that sheet? There is the methods down at the bottom. You see the charts and everything on there. I won't go through the math, but there's an example on there about how to step through it. Yes, sir?
I'm curious as to why they used 130 degrees as the designated temperature rather than like a lower temperature. I've seen it on like 140-pound tanks before where part of the calculation is basically figuring this out, but they want to know the refrigerant at 77 degrees rather than 130.
Very good question. So, okay, so the question is, why are we using 130 degrees as our refrigerant density on this chart? And the simple answer is DOT regulations. Okay, 77 degrees comes from AHRI Guideline K, which is the AHRI's guideline to tank filling. DOT says we need to calculate it at 130 degrees in order to transport it down the road. The density's less because it's warmer, so it expands a little bit more. So DOT knows that, hey, guess what? Our trucks get hot. All right, so that gives you a little bit of cushion in there. So that's why this chart is based off 130 degrees rather than the 77 degrees for AHRI Guideline K. And you're welcome to look up. AHRI Guideline K is free for anybody to look up on the web if anybody wants to look that up and read that whole chart. So it's I don't know, it's 2 or 3, 4 pages long maybe. But basically it outlines how you're supposed to do all this stuff, which is kind of what I put on that chart right there. Now, if you ever do get a tank that releases, the safety release is typically right here on the back of your double valves on that. Okay, it's going to come out through this hole most of the time. You see that red piece in the back of that tank. So if you were to overfill this tank while you're working next to it and that happened to be released, if I was standing here or working next to that tank, that thing's going to shoot a bunch of refrigerant out right at my leg, at my face, at my arm, whatever. We don't want to be sitting next to that. Also, we don't want to have that in our truck if it were to release. So how many of us drive down the road every day in a truck where your driver's compartment is attached to your cargo compartment? A lot of us, right? Yeah? I mean, that's a pretty common truck style in this industry, is a van. If you hear gas starting to leak out in the back of your truck while you're driving down the road, what are you going to do? Well, the first thing I'm going to do is roll my window down. Okay? And then I'm going to play like I'm Ace Ventura. Okay, I'm going to hang my head out the window and I'm going to make siren noises because that tells everybody in front of me to get out of my way. I'm pulling over. Okay, how's that go? Yeah, we're not going to go there. JD, can you come up here and demonstrate that for me? Okay, never mind. Anyways, yeah, you want to be thinking about that. Okay, I've seen what happens when you overfill one of these tanks and this releases. I watched it happen one day in the field by accident. Okay, and this is very important because I have watched a lot of people walk up to a unit. In fact, I've probably done it at some point in time in my career. We walk up to the unit, we take our scale out of our truck first off, we measure our tank weight. We say, okay, my tank weighs X. I walk up to a unit, I've got enough room in this tank to hold all the refrigerant that should be in this unit according to the name tag. Okay? And that's great. And then maybe I'm working way far away on a rooftop and I don't carry my scale up there because, you know, it's extra weight to carry that scale halfway across a roof and up a ladder and through a building and everything else. I leave it down in the truck. I'm going to fill my tank. Well, guess what? You have no idea how much refrigerant is actually in that system. What if somebody else has been there before you working on that and added a bunch of extra charge? Okay, I've seen this happen. And the guy actually had a scale on it, but he was around the other side of the unit working on the other side of the unit at the time. And wasn't really paying much attention or enough attention to his scale, and he overfilled the tank. It caused it to release. That's an accidental release, and it's an honest mistake, but it's one that can be a safety hazard for us. So make sure you're aware of that. Make sure you have it sitting on your scale. Yes, sir. Question from online.
Ricardo wants to know online, is there any way I could probably type this into, or could you write out the formula for converting the weight of the water into refrigerant, or vice versa?
It's on this sheet. So wherever this sheet is online,
which is
which is available online. Yep. The formula is down on the bottom of that sheet.
Okay.
That answer the question?
Yeah. Yep.
Yeah, and you guys can email it, right?
Yeah, we can email it out.
Perfect. Okay, Ricardo, hopefully that answered your question. Thank you. Good question. All right. Now, any questions on this? Okay, so make sure you're weighing your tanks, watching the weight as you're going in, not overfilling them, okay, because it can be hazardous for you. I don't see very many guys getting pulled over and checked by DOT, but it can happen once in a while. But it's more of a safety thing for me. And I want everybody to be safe and be able to go home in one piece every night, if possible. Yes, sir.
There's a practice that some guys, because of the restriction of the dip tube, turning them upside down when they're recovered.
Mm-hmm.
That goes off. You've got liquid coming out instead of gas.
Mm-hmm. Yes. It is a practice and it does work, and we're going to talk about that in a little bit. How to do that, how to flip that tank over and use that. But good point. Yeah, there would be typically liquid coming out of there as opposed to gas. But even if you get gas coming out of there, it shoots out a number of feet, and if you're in the range of that, you're going to get cold really fast. Really, really cold. Really, really fast, and we don't want that. Okay, now let's talk about some recovery connection methods. Any more questions on the tank safety in that? Okay, good. So let's talk about some connection methods to hooking this up to the tank, and let's see if I can get all this in there. Have you got a good view on that from the camera so you can see the valves and everything over there? Good? The whole thing. How's that look? Better? Awesome. Got to dig my extension cord out here. Okay. So most times we're going to use a manifold a lot on smaller systems. A lot of people use a manifold. I've gotten away from manifolds personally because I like to have a little more flexibility than what they offer. So I tend to use hoses coming off of my valve core tools to go into the recovery machine. Okay, we're going to use the G5 Twin here tonight. Very good machine, still my favorite machine on the market today as far as usability. Now, anytime you hook up a recovery machine, you need to have a filter dryer on the inlet side of that machine. Okay? The filter dryer is there for the purpose of protecting that machine from any particulates that may come out of the system with the refrigerant. It's not there to clean the refrigerant. It's not there to dry the refrigerant out. It's just there to grab any particulates before they get into the machine. Now on this machine we also have, inside of the inlet fitting, we have a secondary filter screen that is there to protect the machine in case the filter dryer were to fall apart. So you will find that inside of the inlet fitting, there's a filter screen in there. Okay? For all you folks watching at home. Now, large hose between the filter dryer, okay, as opposed to the smaller 1/4 inch hoses, gives us a little bit less restriction on that. Okay. And then I also use 3/8 hoses everywhere when I make my connections between the system and the recovery machine, as well as the recovery machine in the tank. The methods I'm showing you here today, I've used, I like them. They make it easier, they make it faster. Use whatever methods work for you. Okay, there's a lot of different ways to get from point A to point B. Don't be afraid to play around and experiment and find something else that works for you. But like I said, these have worked well, and that's why I show them off here. Now, at this point, I've got 2 hoses, right? No, 1 inlet. So I've got to be able to couple those 2 hoses together. To do that, I take another core tool. Now these core tools, I kind of consider them a multi-function tool. They're a valve, they're a T, they do a lot of different things for me. So I'll take the core out of that side port, and what I will do is I'll figure out which side my liquid is settled in. Liquid always goes to cold when you're talking about a refrigerant system, so the coolest spot in the system is typically where you're going to find the majority of the liquid. So we'll say that bottom one is the liquid, and I will put that in my straight fitting, and then in the side I'm going to put my opposite hose, which is going to be mostly vapor, okay, at that point, and then hook it up onto the inlet of that filter dryer. Okay, this gives me high flow hoses going into the machine. It also allows me to have hoses that are not my normal gauge or manifold hoses if I'm pulling refrigerant or oil or something like that out of the system that has contaminants or something else in it. I don't want to put that in through my charging hoses, because if I'm going to use those hoses to go charge the new system or the repaired system after I'm finished, I don't want to put those contaminants right back into a new system or a cleaned system, do I? I want to be able to get those out and keep them out of there. So this gives me the opportunity to do that. Now, coming out of the recovery machine going into the tank. This was mentioned a little bit ago. We have 2 connections on the top of a tank. You have one for liquid and one for vapor. What's the difference between those 2 ports? What makes one liquid and what makes one vapor? Right, so there's a dip tube on the liquid that when this tank is upright, it goes down through the tank. Well, that's an added restriction that we can get rid of. Okay, so we hook it to the vapor side. Now, which color handle is liquid and which color is vapor? Except on the tanks that it's not. It depends on the tank. That's kind of a trick question, because you really need to read what it says on top of these valves. I haven't found a rhyme or reason. Some tank manufacturers do it opposite. Sometimes it was a Monday or a Friday or a Wednesday and they changed the colors. I don't know. I can't figure it out. But I'm going to hook that up to vapor. On this one, blue is vapor. When I'm moving liquid, when I have liquid coming out of this machine, because this machine will take vapor and condense it back to a liquid as well as it's coming into that tank because of the airflow going over the coils. So when I'm moving liquid, I'm going to flip this upside down. That gets rid of my restriction, and it fills the tank from the bottom up, because if I go putting the liquid directly into the top of that tank, it tends to expand and flash some of it off to vapor immediately. And we want to try to keep it as liquid as much as possible in this tank. Okay? Now, so I'm going to fill that up with liquid as much as I can until I'm done pushing liquid out of the machine. Depending on the system, I may open up only the liquid port first, okay? Or I may open up both ports. Depends on the system. I may try to pull liquid out first. Yes, question?
Joseph has a question. Wouldn't the plastic tube sending the refrigeration to the bottom of the tank minimize re-expansion after the liquid level is above the bottom of the tube?
It can, but it also acts as an extra restriction. The length of that tube acts as an extra restriction. It's not a real big diameter tube in there. Some of them are pretty small. So with trying to minimize our restrictions, this will help with that. But if we fill it up from the bottom up, we're putting it directly into the liquid in the bottom of the tank, and it helps keep it in that liquid state. Okay? Now, when we're done with liquid, with this setup, I don't have a sight glass, I don't have any way to tell what's coming out of this visually. What can I use to tell when my liquid is finished, when I'm done with liquid coming out of the machine? What tool do I have?
Well, I don't know if it's a tool, but the hose shakes when liquid goes through it.
It can, sometimes. But there's a tool that we just talked about. So liquid has greater density than vapor. Yeah, you're sitting on a scale. You're watching how fast that scale is rising. When it slows down and tapers off, then you're done putting liquid into the tank. At that point, you want to flip your tank back over and set the vapor in on top of the liquid so that you're not just boiling it up through that liquid. Make sense? Okay. Something else that I've done with good success is when I'm cooling a tank, all right, a lot of times we need to cool that tank down just a little bit, okay? Grab some rags and your pump-up sprayer and put some water in your pump-up sprayer, put wet rags around that tank and just spray it down with water rather than having to run a hose or run a whole big bucket of ice to wherever you're working on. It'll help cool the tank. Yes?
Ricardo again wants to know, isn't that a recovery machine? Isn't a recovery machine like a compressor, and so it should be vapor in and vapor out?
No. Not all recovery machines. This recovery machine moves straight liquid through it. Okay? We want to run this with the valves open. Okay? And the valves need to be 100% open on this machine, and I'll show you why here in a little bit when we get to that. So with this setup, all right, now we're going to pump everything into the tank. We're going to fill the tank. Make sense? Okay? The first thing you do when you're done with this, with the G5 Twin, when you're done filling the tank, your system is down to zero pressure. Now, if you're measuring pressure, which you should be, you need to measure pressure back here at your side ports on your core tools. That's going to be your pressure measurement point. You can use stubby gauges, you can use your manifold, whatever you want to do right there. But this allows you then to shut these valves off and isolate that system and see if it rises. Okay, and that's spelled out by the EPA what you have to do at that point. Okay, I'm not going to go down that road today. But yeah? Okay. So these are your access points for pressure. That allows you to isolate everything else You can let it set there, let it rise, do what you need to do, and then open them back up, if you need to recover more out of it. And then they're already on there. You can control the nitrogen. You can really quickly turn that off if your system is setting idle. All right, because if it's setting idle, you don't want to leave that open because then you can have different things coming into the system. So that'll close your system to atmosphere. Now you can take your hoses off. But when we get done with this, shut the power off. Don't turn any valves. Okay, don't turn the valves on this machine. What I'm going to do right here is I'm going to fill this hose up. Let me grab an extension cord. We're going to turn this on. I'm going to fill this hose up, my discharge hose, up with just compressed air today. And I'm going to show you a little trick here. So the first thing you want to do is turn the power off, close your tank, and then you can disconnect the inlet side. So we're just going to fill this with air. We'll put a couple hundred PSI in it. Okay, so what this is simulating right here is when you're done with a refrigerant recovery, you're going to have a hose full of high pressure, typically liquid, maybe liquid vapor mix sitting in this hose, right? Right? And when you go to pull one of these connectors off, what happens? You get a handful of refrigerant, okay? Now, on this inlet valve, remember, on a lot of machines, they have a throttling line or a throttling point on that inlet valve. When you're running liquid refrigerant, you need to throttle that. This machine, do not throttle it. Okay? It needs to stay wide open. Between these two valves, there's a passageway. And if you throttle this machine, you're opening up a passageway between the high side and the low side that's there for equalization and also for back bleeding this hose. Okay, so what we do now is now I can turn this off to 45. I just bled that hose out without having to get my hands near anything. And now I can disconnect this hose without worrying about getting fingers burnt. All right. Whoops. Okay, any questions so far? Yes, we have an online question.
Yeah, Ricardo again wants to know what Appion model is it that accepts liquid both in and out?
The G5 Twin.
Okay.
Yes. Pump 100% liquid refrigerant all day long. All right.
Before you go on, I noticed that your connection ports on the recovery machine are angled.
Mm-hmm.
Mine are not.
You're correct, they're not.
Where did you get those at?
This is something new we just brought out this year.
It is time to sell them.
Yes, they're for sale at a lot of places. If not, ask your distributor. Yes, so Kyle over here is asking about the angled connection ports. If you want to zoom in on these, the angled connection ports on this machine, the kit part number is KTG635, if my memory serves me correctly. I can put that in the notes, I believe, later on, if anybody wants to know that kit part number. But it's a retrofit kit for the G5 Twin to be able to retrofit them with an angled fitting. Yes, sir.
Is that in the Appion magazine?
Yes, it should be in the back, the very back page of the catalog, or back to.
1/4" swivel fitting retro kit?
That's correct. Yes.
That is the KTF 645.
KTF 645. Thank you, sir. So that's your swivel fitting retrofit kit for the G5. And it comes with both sides. Yeah, it was a great improvement. So, yeah, it does. Which is why we originally started making these hoses. Yeah, why we started making that hose, and then this year we brought out the large diameter hose. which of course reduces the restriction even more. Now, so that technique right there was called direct recovery. That's where we're pulling it out of the system through the recovery machine and pushing it into the tank. There's another good technique out there for recovery if you get into larger systems. And I typically wait until I see 25, 30 pounds of refrigerant or more, and I can access liquid in the system directly. And that's a bad thing to do. I don't like to drop hose ends on the ground. And this is called push-pull. So I kind of want to show you guys what push-pull is. So inlet side of the machine gets hooked to the vapor port on the tank. Now this case, we're going to run the liquid into the liquid valve out of the system. So we would have liquid going into the liquid valve. And again, something I didn't mention before is you do need to purge all hoses before you start running your refrigerant through it and putting it into the tank. You need to purge all the air out of there because you don't want to go sticking a bunch of air into your recovery tank. Right? So this is a push-pull technique. Path of the refrigerant. Liquid refrigerant is going to come out of the system, go directly into the tank. The machine is then going to pull vapor off the top of the tank, right, through the machine, and push the vapor back into the system, thereby pressurizing the system to force the liquid refrigerant out. Now again, you need to be able to get to 100% pure liquid refrigerant, and you need to have a good volume of it. You know, my cutoff, like I said, typically 25, 30 pounds of refrigerant, and I want to move it real quick into a tank. Maybe even more than that to do a push-pull. Because one of the downsides of push-pull is once you get done with the liquid, you got to reconfigure everything and do your direct recovery to get the vapor out of the system and put it into the tank as well. So that takes a little more time. Yes?
Is there any concern with contaminants or anything with that method?
As far as...
So you're going directly into the tank, or does that not come into play?
That really doesn't come into play because you're going to put it in that tank. If it was clean enough, you can reuse it. If not, then you're going to send it off to have that refrigerant recycled, and it's going to be recycled and cleaned up at the recycler. But the contaminants, you have to watch. I still have my filter in. That's protecting the machine from contaminants because the machine is what I want to protect. Makes sense? Okay, so the question was, for those of you who didn't hear it, is there a concern about contaminants going into the tank for this, with this type of a system? Anyway, as I said, when you're done with this, you need to hook up direct recovery to be able to do pull the vapor out and put it into the tank as well. So there's a little bit more time there. However, you can save a lot of time by doing this method if you have large enough volumes of liquid. So it's a trade-off. Again, that's one of those things you just have to know the system and know what you're doing with the system to be able to determine what technique you're going to use. Any questions on that so far? Yes?
I don't know if you've covered this at all or not, but in addition to using a scale, I keep an eye on the gauges right on the machine. And I have stopped tanks from going over by watching that gauge. And if I hit 350, 400 PSI on that right gauge on the machine, I cut it off.
Yeah. If you're starting to hit 350, 400 PSI, that's when you need to start looking at cooling your tank.
You're right.
Yeah, and you can shut the machine off at that point. Now the machines have a 550 PSI internal safety. So if you're hitting 550 in that machine, because where that gauge is at, you're measuring pressure right at the discharge point of that machine. So this is going to read higher than what's in that tank.
Right. Could you repeat what was his question?
Yeah, asking about talking about using the gauges on the machine to stop it and stopping at about 400 PSI. As I said, this has got 550 PSI cutoff in it for safety reasons. Okay, because of the difference you're going to read here versus what you're going to see at the tank.
And when you have them wide open, they're internally checked, aren't they?
As far as, okay, so when you have the valves wide open,
Yeah, on the machine.
yeah, so what do you mean by internally checked?
If I had them wide open and I disconnected the inlet hose, it wouldn't feed back from the tank, would it?
No, it's not going to feed back from the tank. So inside the machine, there's valves out here in the valve plates, and that's going to stop it from backfeeding out there. Because you saw right here, when I shut that off, it didn't backfeed any of that air back out. Yeah, correct, until I opened this up and it allowed everything to come back out. Okay? Good question, though. All right, let's get this stuff out of the way.
Is it hard on the reclaimer that, so basically when I go to reclaim to bleed my hoses,
Mm-hmm.
I let the machine fill up and hit its 550 pressure limit, bleed them off, and then open up my valves on the reclaim tank. Is that bad for the machine?
So to bleed the machine,
To bleed the air out of my refrigerant lines,
okay,
I basically turn everything on, let it pump to where it hits my ball valve on my hose, bleed it off, and then hook it up and let it go.
okay, so
It's hard on that machine to keep doing that every time I go to reclaim. Any way to summarize that?
So we're talking about purging the machine. The way that I purge this machine, all right, is I supply refrigerant out of my system. All right, so I supply pressure up here. I close my outlet valve. Okay, inlet valve is open. Machine is not running. You don't need the machine running to purge it. Okay, then I'll take the discharge hose. We'll say this is the discharge hose on here. And I have that discharge hose open to air. I don't have it hooked up yet. Okay, so I'll crack this valve just to where I start getting purge out of here, and I let it purge. And as it's purging, then I go screw it onto the tank. Okay, because that way it's forcing it out as I'm screwing it on. I'm making that connection, then I'm good. Then you can open up your tank valves, and this will allow flow through it. If you have a high if you've got a vacuum in this tank beforehand, which, if it's an empty tank, you should have a vacuum pulled on it. It'll allow it to flow straight into that tank if there's a pressure differential, if the pressure in the system is greater than the pressure in the tank. And then once it's flowing, then you go over here and you turn your switch on after your valves are 100% open. Okay? Yes?
Another question online, Ricardo wants to know, how do you compute and maintain 80% capacity of the tank to follow the EPA ruling? Where do you base it from? The WC, the TW, or the total tank weight after recovery?
Okay, so WC is your water capacity in the tank. So you're going to take that water capacity, you're going to multiply the water capacity times the refrigerant multiplier, which is on the sheet, and then you're going to multiply that number by 0.8, and that tells you how many pounds of refrigerant you can put into the tank. Then, if you want to know the total maximum tank weight, you combine the refrigerant weight and the tare weight, and that gives you your total tank weight. That makes sense? I think that should answer his question.
Yeah, and
okay.
Anybody can just so everyone online knows, they can download this. This file is available while
Yes.
they're watching this online.
Yes.
And I think it's called the tank weight multiplier.
Yeah, it should be
file.
called the tank weight multiplier file. So you can download that and have a PDF of it. Yes?
Is there any preventative maintenance schedule for those recovery machines?
There's no preventative maintenance schedule. There's a periodic test you can do as necessary. Takes about 2 minutes to do the test. So I can show you how to do that here real quick.
I'm putting that machine through 3 to 4 installs a day.
Sweet. That's good, huh?
5 days a week. So I have 7 of them.
Mhm.
Along with the I got 7 of them, so we're putting it to the test.
Putting it through the paces. Good to hear. So the question was about periodic maintenance on the recovery machine. There's a periodic test to do. You repair it as necessary. The test is real simple. Start out with the both valves open, machines plugged in. You will need a timer. Handy dandy cell phones, most of them have a timer of some kind on it. And what you're going to do is you're going to turn the power on, all right, and close the inlet valve. As you close the inlet valve, start your timer. And time the amount of time that it takes. Okay, so you want to time the amount of time that it takes to hit that high pressure switch. It should take less than 30 seconds. If it takes longer than 30 seconds but less than 45, you're getting close to needing a rebuild. If it's over 45 seconds, you need to rebuild the internals in it. Okay, and we sell the rebuild kits. You can do it in the field. It takes about an hour, or you can send them off to us. Contact Appion directly. You can get it off the website, appioninc.com, or on the back of the catalog. And you can send it in and have it rebuilt. Now, once you're done with it hitting that high pressure switch, turn the power off, and then you're going to quickly close the inlet valve and equalize both sides. And this should lose, I'm going off memory here, I think it's no more than 10 psi a minute. If it drops faster than that, then you've typically got problems in your valves internally. So that's a test on the rings, a test on the valves, the ball valves out here, the valves in the compressor, everything else. Okay? And that tells you whether or not that pump is working properly. If you never need to know how to do that test, jump on our YouTube channel, the Appion YouTube channel, and it details, it's got a whole video series on how to test these, how to rebuild them, everything else on there. So pretty easy to do. If I can figure out how to do it, just about anybody can figure out how to do it. Okay. Now, any other questions? A lot of good questions there. Awesome. So, let's move on to vacuum. All right. So, vacuum hose selection, and I'm going to talk here a little bit while I'm doing some other stuff. While we're kind of getting this hooked up, because we're going to use this recovery tank here as a demonstrator for a little side-by-side vacuum comparison. Now, with vacuum hoses, okay, we want to pull a vacuum. How are most of you pulling a vacuum right now in the room? What are you using to pull a vacuum as far as connection between your vacuum pump and the system? Okay. Straight to the pump? No manifolds. Good. Manifold? Okay. You may change your mind when we're done today. I'm just telling you. Hi, Joe. How you doing today, sir?
Fabulous.
Good. I just had another attendant come in the back of the room for all of you folks online. Okay. So when you're selecting a vacuum hose, one of the things to consider is flow. Okay? And when we're talking about normal manifold hoses that a lot of us use for years, this is what I was taught on, we use 1/4-inch hoses. Okay? Now, a 1/4-inch hose is great for testing pressure. Okay, it works. It puts pressure from point A to point B. But when we're talking about vacuum, it's a pretty giant restriction. Pretty giant restriction. Okay? To illustrate that, when we are pulling through a hose just like this, hooked onto a port, like so, where did the, oh, I lost my, my demonstrator units. They're stuck in the back of the room. Anyway, so when we're hooked on with a 1/4 inch hose to a standard port with a core still in it, anybody want to guess as to how many CFM I can move through that hose? With the core still in it. 2? Anybody else? It's a lot less than 1. It's about 2/10 of a CFM. Now, how big is your pump? Okay. 6, 5, 6 to 8, yeah. So if you can move 2/10 of a CFM through one hose, how many is that through 2 hoses and a manifold? Yeah, are you using your pump? Not much of it. All right. Now, if I take that same hose and I put core tools on it, like this right here, how many CFM you think I can move through that? 2? Anybody else? Little less than 1. Okay, it's about 8/10 of a CFM. You improved. That's a 4-time improvement. I mean, that's a pretty good sized improvement just by taking that core out. It's a big difference. But we can go better than that. Okay, we got bigger hoses. We can step up to about a 3/8 hose. Okay, a 3/8 hose is also going to flow more than that 1/4. Okay, we're going to use that same core tool on there. We've got some higher flow fittings on the ends of this, right? They're bigger diameter, so if you compare like a standard 1/4 inch hose to that, you can see it's larger diameter. So we get higher flow, means less resistance right there. They're also straight. So you can use this for vacuum as well. It is a vacuum rated hose. Okay, we can do about a CFM and a half through a 3/8 hose with 1/4 inch fittings on it. Okay, so again, that's an improvement. We can improve that. Now, if we want to improve it even farther, okay, we can step up to a 1/2 inch hose. Any idea what this will flow?
3/8 does, you said 3/8 at 1.8?
So, yeah, about 1.5. So this is a 1/2 inch hose. It's got a 3/8 fitting on one end to go to most vacuum pumps, because most vacuum pumps have 3/8 connections on it. And it's got a 1/4 inch fitting on the other end to go to your system. You can do about 3 CFM with this hose. Okay? And the fittings are a little bit of a restriction, but they're straight through. They're as high flow as we can make them. But we're limited to what kind of connections we can make onto our system and onto our pumps typically. But having that hose in there, that larger diameter hose, reduces the flow restriction so that we get a lot higher flow. We get our job done faster. All right? So to accomplish this, we're going to make our connections from our core tools. You know those handy dandy core tools we have on there? We're going to make those right over to the pump. Straight to the pump. All right? Now I'm kind of jumping ahead of myself here because I told you this was going to be all about hose selection. So we're going to hook this up and change up a little bit on here. Now, a couple things on these hoses. They are also a pressure rated hose, so they can be used for high pressure. This is a charging hose. Okay, this is a standard charging hose. This is a pressure rated vacuum hose, or a pressure hose that's also rated for vacuum. This to me is a big safety piece that I like to have. Anybody in here, and I'm sure somebody online has done this, have you ever hooked up a system or hooked up your vacuum pump while there's still pressure in the system and accidentally applied pressure to your vacuum pump? Once? That's all it takes is one time. You learn that lesson real fast, don't you? Yeah? What happens?
Everything went flying out of the handle of the JB.
Yep, you lose a lot of oil out of that vacuum pump really fast. Okay? So to me, having a pressure rated hose is important because if I accidentally apply pressure to that, I want to know that it's not going to blow up on me in my face. All right? So that to me is an important piece. I'm a little crazy about safety sometimes. Because again, I like to be able to go home in one piece at night, and I like to see all you guys go home in one piece at night as well. Yes,
Ricardo wants to know, so there's no need to hook a Micron gauge?
we're getting to that.
Okay.
Tell Ricardo he's got to keep watching. Okay. Yep, we're going to talk about a Micron gauge here in a little bit. Okay, so that's going to be our basic system connection. All right. Now, we're getting to Micron gauges. Let's talk about gauge selection. Okay, there's a lot of different kinds of gauges out there in the market. There's a lot of gauges that I consider good. There's a lot of gauges that I consider not so good. All right. I really enjoy working with the Appion gauge. This is one thing that I have enjoyed from a gauge perspective. Whatever kind of gauge you have, you want it to be a standalone gauge that sets out away from the unit. You don't want to have this in a manifold. All right. One of the enemies of a vacuum gauge is oil. Vacuum gauges don't like oil because of the sensor in there, because of the way they measure. They're actually measuring pressure based on temperature. That makes sense? Yeah? Okay. You understand what I'm talking about? Okay. So for those of you who haven't seen it, inside of a vacuum gauge sensor, essentially we have a heater, we have a temperature measurement device, and they're a small distance apart. And it varies a little bit to how the sensor, but this is kind of a simplified way to describe it. And inside that sensor, the heater puts out a known heat content. And as we pull a vacuum, we remove molecules from inside that gauge housing. Because we're putting out a known heat content, we translate the amount of heat that the temperature sensor is seeing into a pressure. So if you put oil in between those two or coat any of that with oil, it changes the reading and it changes the accuracy of it. Make sense? So we got to keep oil out of a Micron gauge. Yes?
Patrick wants to know from AirTech, do you see manufacturers going to larger connections?
Larger connections on systems. So I see manufacturers trying, but I haven't seen anybody being successful at it yet. Yeah, it would be nice from a lot of aspects, but on the other hand, it's going to cause a lot of new tools and it's going to cause a lot of confusion in the industry if they were to do that. And it is in some cases right now causing some issues. There's one out there that's used called CoreMax, and it's been a little bit of a problem because it requires some specialized, really expensive tools to be able to work on that. So at this point, personally, I don't see the industry changing a whole lot with regards to making bigger connections on units. At least not on smaller units. Maybe big industrial units or something like that at some point. So, but good question. Now, another thing on a vacuum gauge, you want to have the ability to be able to read from atmosphere all the way down to 1 micron. Okay, and that's one thing that I really enjoy about this gauge versus some of the other gauges that I've used over the years, is that I can see exactly what the atmospheric pressure. Right now we're at 741,000 microns. Now just to show you how sensitive this gauge is, all I'm going to do is tighten this cap down on here, right? So all I'm doing is compressing the gasket in this cap. You see the change in that? We started out at 741,000. Just tightening that cap, now I'm at 753,000 microns. Just by tightening the cap on there and compressing that gasket. That's what changed the pressure in there just that much. It caused those molecules to tighten up just a little bit more. All right? So we want to be able to measure from atmosphere all the way down. And you want to have a good vacuum gauge. A good measure of a vacuum gauge is what's called Nist calibration. All right, so, or Nist Traceable calibration. Nist is the National Institute of Standards and Technology. Right? They set standards and everybody else compares against those standards. So when you say a Nist Traceable calibration, it means that it's been tested against a standard, a known standard, to be accurate. And Appian does a 10-point Nist calibration on all the gauges we put out. And you can get a calibration certificate to go with all of our gauges as well. All right, and if you need to have them recalibrated, you can go back and have them recalibrated.
What's the cost of that?
The cost of that, I would have to check. I don't know off the top of my head. Good question, though. Cost of calibration, I'm not sure off the top of my head. We can find out if you have one that you need to go back in. Okay. One time you need it calibrated, or one time you use the gauge? You didn't break it, did you? No. Okay. They're pretty durable, but anything breaks sooner or later. I don't care what it is. Everything's going to break at some point. Now, so that's a little bit about gauge selection. There's some other things you can talk about when you're selecting gauges is Bluetooth. A lot of things have Bluetooth on them, so you can download it onto your phone. You can do data logging. You can do all kinds of stuff with that, which is a very useful thing if you're doing turnout packages or commissioning packages and things like that, to be able to have a record of what you did onto a system. Okay. Yes, online question.
Robert online wanted to know, is there a good way to clean out, or a best practice to clean oil out of the Micron gauge?
So this gauge, yes, that is really up to the manufacturer of the individual gauge. To clean this gauge, you unscrew the fitting off the bottom of it. Okay, inside this fitting there's a check ball that attempts to keep oil out of this gauge. Believe me, I've seen people put oil in it. It can still be done. Inside of that housing, you need a screwdriver or a pocket knife of some kind to pop out the oil mist filter, right, which is this little white piece. And inside of that, there's a screen that keeps that oil mist filter. And there's two holes in there which have our high and low pressure sensor. We use denatured alcohol or isopropyl alcohol to clean that sensor out in there. And the procedure is laid out in the owner's manual as to the cleaning of it. Hopefully that should answer. I think that answered his question. Okay, good. Now, the other piece you want to have with a vacuum gauge is a metal connection, some kind of a metal connection to go on the bottom of it to hook it onto the system. I prefer to have some kind of an angled connection, because keeping oil out of it, if I can keep it upright, I don't get any gravity drain, versus having it hanging down. I can get gravity drain of oil going down into that gauge. Okay, so that's a little on selection. Now, to measure the vacuum in a system. Yes, sir, in the back row.
The angled gauge, the angled tube there, there's a proper way and a not proper way to install that onto your micro.
A proper way and a not proper way to install the angled tube. Okay.
One is to make sure that you have the depressor right in the.
Well, there is a depressor, and if you're going to use the core depressor to access the valve, yes, you need to have that core depressor that's in the metal fitting placed away from the gauge. You are very correct, yes. However, I'm going to show you a little trick here that you don't need that core depressor. Okay, how about that?
Real quick, Ronald had a question online. He wants to know, at what micron level do you start to boil the compressor or vac pump oil?
Less than 10 microns. It's a good question, okay? We really don't have equipment in this industry that will do that. But that was actually, there's a thing in the industry that was taught for a lot of years that you can actually boil refrigerant oil, boil compressor oil, if you pull too deep of a vacuum. And I had this question, and what I did was went to an oil engineer at an oil manufacturer, and I asked him, I said, hey, what does it take to boil this oil? And he said, you can't with your equipment. So hopefully that'll answer that question, I think. All right, so when we are measuring vacuum, all right, we're measuring vacuum in microns, which is, the full name of the scale is microns of mercury. It is a thousandth of a millimeter, is a micron. Okay, so it relates to the millimeters of mercury scale. Now, when we're pulling a vacuum, the idea when pulling a vacuum is to remove non-condensables from the system. Basically, we want anything that's not going to boil and condense, a gas or a vapor, that's not going to boil or condense out of the system. So we want everything that's not going to boil or condense at the same time as the refrigerant out of the system. In order to do that, we use a vacuum pump to create a low pressure point, all right? And the low pressure point at the vacuum gauge causes everything in the system to flow through the hoses and out, and then the vacuum pump rejects it. With that in mind, where do we want to measure our vacuum pressure at? In the system, right? We care what's in the system. I don't care what this pump is doing. Yeah, that's a good spot. My rule is as far away from the pump as I can make that. As far away from that pump as I can get my gauge. Okay? So, yeah.
Do you have a preference, or does it matter at all, liquid or vapor line? On what side you put your gauge on?
Do I have a preference, liquid or vapor line? I tend to try to put it on the part, and we'll talk, actually I'll talk about that in a little bit. How about that? Because I'm going to get into something else to answer that question. Now, we want to measure it in the system. If we measure it at the pump, we're going to see an artificially low pressure, which that was where I was taught to measure it when I started in the industry, was at the pump. And the guy that was teaching me said, hey, you get a really fast vacuum there, right? Yeah. Well, you do. At your pump. Doesn't do so good over here in the system. This is our simulated system today, by the way, for those of you watching along. What's that? Yeah, it is a very quiet system. Very quiet system. Okay, so it's not really efficient. No, it doesn't do much cooling at all. Now, when we make a connection, on a lot of systems, you're not going to have any more than 2 ports. So you're going to want to put your vacuum gauge onto a side port. My preference is to put it on a side port closest to the largest internal volume in the system. A lot of times that's going to be your suction side close to your compressor. I want to find that gauge at the highest internal volume, and I tend to like to have it somewhat closer to where the refrigerant is going to come out of the oil, because that's going to have my pressure rise mostly. Now, you comment earlier about the core depressor on here. So the thing on vacuum gauges, like I said earlier, is we got to keep the oil out of it. We need to keep that oil out of that vacuum gauge. Keep it upright while you're pulling the vacuum, because that doesn't allow anything to gravity drain if you're working on a system and doing service. However, when you're done pulling a vacuum, you're going to put pressure on that, and you're potentially going to push oil around in that system. Okay, and you can potentially push oil up into that vacuum gauge. Say if you're on a new system like a residential split, you open that valve up, you're going to get a rush of oil and refrigerant coming out of there, chances are. So, pull the core out of the side port, add another valve tool. Okay? Because guess what? It's a ball valve. It shuts things off. So this allows me, when I'm finished with my vacuum, okay, I'm all done with this vacuum now. Finished with that. Now I would close these 2 valves off. I'm going to do a rise test. Remember that side port's always open to the system. Okay, my rise test passes. I'm all finished. Now I walk over here and I turn this ball valve off. Okay, my gauge is now isolated from the system. I can take that gauge completely off, lay it over out of the way, and I'm done. I don't have to worry about damaging that gauge. I can also take my hoses off of here, right off of these ports. If I need to add refrigerant in, if I'm doing service on a system, it's fully empty. Now I can put liquid refrigerant directly into there, and believe me, you'll run a lot of liquid refrigerant through that core tool really quickly, so be careful. It's going to go in fast because it's not going to be metered like you would if you had a core in there. Okay, so that's a little bit there. Now, let's get to vacuum pump oil, and then we'll talk about actually doing the vacuum pump and testing it, and we'll run it here for a little bit, and I'll show you guys a couple other things. So, oil. In the vacuum pump, oil is a very important thing. It does typically about three main things. Somebody help me out here. What's one that vacuum pump oil does? One thing. Catches water. Okay, that's kind of a minor thing. We'd actually rather it didn't if we could stop it, but it does. What else does it do inside that pump? Cools it, lubricates it, right? The other thing it does, the big thing it does, is it creates the seal on the rotary vanes as they're spinning around in there. It creates the seal that allows us to make that low pressure point at the pump. Okay, so it allows us to make the seals in that pump. As we contaminate that oil, as we run the pump, if we pull moisture through there, we force it into that oil, and the vapor pressure on the oil rises a little bit. Okay, and it doesn't create as good a seal, so we can't create that low pressure. So we need to make sure that our oil in the pump is good. Okay, and to do that, what we're going to do is we would use a vacuum gauge. We would hook it directly to the pump with no other hoses hooked on, and this works on any pump. And we want to measure how low that pump will go. So we would hook that right on there. We would measure how low that pump will go. Depends on the manufacturer specifications, how you verify it, but typically I want to see ultimately that the oil in the pump can create less than a 50 micron vacuum. Okay, it may have to run for a little while to be able to do that, but it needs to be able to create that low pressure in order to create enough pressure differential to get everything in the system moving and keep it moving outside of the system. Make sense? Okay, so that's an easy way to be able to check your vacuum pump. Now, when we're talking about oil selection, you want to find good quality vacuum pump oil. There's several different kinds out there on the market today. We have a couple different containers of it that Appian makes. This one works with our vacuum pump, the TEZ8, and that's how we change our oil. It's all in that container. Now, I also use this oil in anybody else's pump. When I was in the field, I loved it because it is hydrophobic. All right, so that means that it doesn't absorb water when you open up the cap. Like a lot of times we were taught to take a quart of oil, fill our vacuum pump up. If you're not going to use the rest of it, you just pitch the rest of that oil, right? We taught that a lot. With this, you don't have to worry about that because it doesn't absorb the moisture out of the air like most mineral oil will. This is a semi-synthetic oil. Most mineral vacuum pump oil will just absorb the water or the moisture right out of the air, and then you end up putting in a slightly contaminated oil if you leave it setting open. Even if it's got the cap on it, it's not sealed with that foil seal anymore to keep the moisture out. So that's oil selection. Oil changing on pumps, again, depends on what you're pulling out. I like to use my gauge to evaluate my oil. I don't necessarily need to change it every time, but when I do, we'll change it at the end of the job while the oil is still warm, okay, and particulates are in suspension. When you're done changing the oil, put all the caps back on the pump or close the valve on the pump and run it for about 30 seconds because If I change this oil, or if you change the oil in a standard pump, you're going to drain the housing. You're not going to actually drain the pump, the internal of the pump itself. You're still going to have a little bit of that old oil left in there. You want to run that pump for a little bit to make sure you get some of the clean oil circulated into the pump housing itself. Does that make sense? Okay? So change it at the end of the job. All right. Everybody getting bored now? How many we got online? Like 3 probably, right? Are we down to 3? We're down to 2? Seriously? Hey guys, appreciate you playing along. Thanks.
There's 70.
70? Hi folks. Thanks for watching. I appreciate it. I hope you're not all asleep. Okay? I know I'm boring, but I hope you're not all asleep. All right. Now, so we kind of talked about, well, we touched on the testing of the vacuum pumps already. I'm skipping ahead of myself here on slides. Okay. So, connection methods. I showed you that 2-hose connection method, right? With putting the vacuum gauge right here on the side port. That connection method is great for service. And when you're doing service, you need to be concerned about oil out in a system, because if you have an operating system, it could have oil setting somewhere. You might not have gotten it out. So if you have an oil trapped or sitting somewhere, you can't pull a vacuum through trapped oil, because the pressure differential is not going to be great enough to get a deep vacuum on the back side of that trap. So you need to access the system from as many points as possible to get the vacuum everywhere in the system. Make sense? Okay. All right, now, if I'm doing residential work or split system work on smaller split systems like commercial, residential, I'm going to use a single hose technique. Okay, so I'm going to hook my, and I kind of did this backwards because normally I would hook this hose up onto the suction line, but you hook your hose to one side, you put your vacuum gauge on the opposite side again, with that core tool in here. Okay? This gives you the gauge as far away from the pump as you can possibly make it. Single hose, new system, everything is clean, dry, and tight inside that system. That's where we want to have it, clean, dry, and tight in the refrigerant system. If we're doing that, I typically see vacuum times of 5 to 10 minutes, no longer than 15 minutes to have a system under 500 and holding, okay, with a single hose like this. That's just how it works out. So that a lot faster, I'm assuming, than probably what you're doing now. Okay, so it saves time. Now, when you've got oil and refrigerant existing in a system, yeah, it's going to take a little bit longer to do that, because you got to boil that refrigerant back out of that oil, so it's going to take a little bit longer, and that's where that 2-hose technique comes in. All right. So that's a couple different connection techniques. Now, if you're getting into bigger systems, if there's anybody watching that's into bigger systems, or here in the room that's working on bigger systems, you may want to do more than 2 hoses. You may want to do 3, 4, 5 hoses. Depends on how many ports you have available on the system. The more hoses you hook up to the more points, the quicker it's going to go down. So we offer the option of a vacuum manifold to go on top of the pump. And this, we sell 2 different hoses. This one's a 1/2 inch by 1/2 inch. Or we have 1/2 inch by 3/8, so you can put it on a vacuum pump with a 3/8 connection on top of it as well. So this will work for other brands of pumps, so that you can make that go faster as well. Okay, and this will allow you to have more hose connections on those pumps.
So what's your internal size on your manifold? I assume it must be larger than.
It's a 1/2 inch bore. So don't use this as a charging manifold, because you're going to hold a lot of refrigerant in that. But yeah, it's large in there, and it is vacuum rated. You don't need to do anything with these valves; just leave them open all the time. All right.
What are they for?
They were put on there just, I think, more as a look, is my understanding. They do operate. They are vacuum rated. You can turn them off there if you want to, but I prefer to have my valves over here and turn it off here. I wasn't the designer. I don't know who the designer was on that. So you can put your gauges on this, but like I said, with that 1/2-inch bore in there, no, I wouldn't put gauges on that. The early ones did have some analog gauges up here, but they took them off because, like I said, it's really, I don't see a use of it for gauges or for charging. It's just for vacuum, and I don't like putting refrigerant and oil through something that I'm going to do vacuum on. I try to keep my vacuum hoses for vacuum, charging for charging, recovery for recovery. That way I don't get into trouble. Okay, now we want to have a little fun here. Where's my, there it is. That's what I'm looking for. Okay, side port on core tool. Can you guys see that? Any of you guys see that? Your eyesight's too bad? How about you guys? You see blue? How about that? Can you see the numbers on there? Just see blue? Any better? You're not that young? Okay.
What's it say?
742,000. So let's have a little fun here. Okay, we're going to hook up a little demonstration so you guys can see what the difference is in speed between the two hoses. So we're going to make a little simulated system. Right? We'll pull a vacuum on this tank. And
You got the Micron gauge on the suction side or on the liquid side?
this one is on the opposite side where I have my hoses hooked up. So it's as far away from the pump as I can get it.
So it doesn't matter if you pull it on the suction side or liquid side, as long as you're pulling from one side or the other?
I would, if I'm doing a single hose technique, I'm going to hook that up to the vapor, the hose up to the vapor side. Because I have a larger internal volume on the vapor side without going through the restriction of the metering device.
Okay, so you mean the hose. You're putting the recovery part on the liquid line, or the suction line.
This is vacuum, not recovery.
I'm referring to a system.
Yeah, but I'm saying this is for vacuum, not for refrigerant recovery.
Right.
Okay?
For vacuum.
Right.
You're hooking it up to the suction side of the system.
Correct. The suction side.
Larger line of the two.
Correct.
And you're putting your Micron gauge on the liquid line.
On the liquid line, correct. Because then this is on a new clean system where I'm just doing the coil and the line set. Because then the only thing that I'm pulling through that metering device is the volume of the liquid line. That makes sense?
Yes.
Okay.
I'm asking because I want to make sure I'm doing it right.
Okay.
I've done it once and I did it this way so far. So.
How did it work?
Well, other than my help turned the valves off wrong, they thought the handles actually turned it off, and it didn't. We had to start over for the second time, which was okay.
Okay. You're doing all right.
And I will tell you this: you did not lie to me.
I told you I wouldn't lie to you.
I know that. But
Okay.
I just want to let you know that I did check. It was about 15 minutes.
Okay. Good. Good. All right. So Joe's talking in the back for anybody that couldn't hear him about a job he just did. And apparently I told him the truth and it all worked for him. So, you know.
Worth every nickel.
Worth every nickel? Good. Glad to hear it. So on this setup, we have the gauge is far away there. Now we're going to add another gauge in on the side of this port here. Okay, and I'm going to give you guys, can you see both those gauges in the camera or not? Yeah? So what this shows is, what's this designed to show is the difference in the speed between a 1/4-inch hose through a core depressor versus going through a 1/2-inch hose with no core depressor in it. Okay? So what we're going to do first, I'm going to turn this valve off, which isolates me from pulling through that 1/2-inch hose. We're going to go through the 1/4-inch hose first. All right? So we will turn the pump on. We'll run the pump for about a minute. Who wants to run a timer? You got a timer over there? All right, so we got a timer. So what I want you to do is when I put this cap on, okay, now this pump needs to have a cap off to start it because it's a soft start motor. So when I put that cap on, start your timer and give me time when we're at a minute. And I want to know, we're going to see what the readings are on there. You got a piece of paper over there? You want to write down some readings for me? Okay, so we're going to start off with 1/4 inch hose, and we're going to measure it at the pump and at the system. And you guys following along at home, you can write this stuff down too. We'll tell you what it is. You ready? Okay, so we're going through just the 1/4 inch hose. We're looking at the pump pressure versus the system pressure over here. And this kind of allows us to see what the difference. Right now we're looking at about 55,000 at the pump and 450,000 in the system. There's a pretty big difference between those two right off the bat. We're just going to see how low we can get over about a minute's time with a 1/4 inch hose. Then what we'll do is we'll switch to the 1/2 inch. So we got 20 seconds to go. We're at 32,000 and 300,000. And we're done. 21,000 and 200,000. So at the pump we had 21,000, and at the system we had 200,000 after a minute. So let's equalize this. We'll fill it back up. And we're going to turn off that 1/4 inch. There we go. We're about equal on those two now. Okay. So let's run this through the 1/2 inch in that same minute time frame. You ready? So again, we're looking at the difference on that. Where are we at? We're 10 seconds in, we're at 145 and about 230 right now. There we just passed 150,000 in the system already. 100,000 in the system. $50,000 in the system at about 30 seconds in. Ten seconds to go. $10,500 and $3,400. Okay, so at the pump we had 3,400, and in the system we had 10,500. After that same minute going through the 1/2 inch hose versus a 1/4 inch hose. All right, so same volume, same air. I just opened them both to atmosphere. That's what the difference can make time-wise. Now you extrapolate that out into a system and you can see it makes it a lot quicker and can be a lot more accurate to measure it away from the pump, as well as using the larger hoses to get things done. Okay, how are we doing on questions? Anybody got questions?
I do.
Yes.
So if you want to test your hoses to make sure that you don't have an issue with them leaking, obviously I would take the pump and then hook the gauge up at the end, but is there a certain decay number you're looking for after you pull it vacuum in that?
I would pull it down typically under 100 microns and see if it will pull that, you're going to get some decay because of the really small internal volume of that hose. You've got to pull for a really long time to get the lining of that hose really degassed well, because it does get molecules stuck on it. And in order to get it really well degassed, it's going to take quite a while to get it to hold at that pressure. But if you want to test it, there's not really a number that I've found, because I don't do that. I really don't do that test. But if you could pull it to under 100 microns, I'm going to say that you're probably not got a really big leak in there. I would have to do some testing to really set up a good number for that, because I haven't really done that test. There's a lot of variables in doing that. You know, how big is the leak, et cetera.
I had an issue with the same setup, and I kept having trouble pulling the vacuum, and I thought it was leaks in the system, and then I rebuilt my core tool, and then after that, I thought, well, it's got to be the hose, and it was in that the core tool just wasn't rebuilt right was the problem, but
Okay.
I was just trying to figure out if there's a better verification.
Yeah. So when you're talking about verifying things like that, so the question is there a way to verify hoses and components? The best way that I can think of to verify that is process of elimination. So you have to start putting things together and eliminating them, or adding in different things and seeing when it starts to leak worse or stops leaking. But I mean, that's a good question. It's not something I've had a lot of problems with on the hoses. Keep your gaskets, hose gaskets, replaced periodically. Like if you're using the Appion hoses, we do have specific hose gaskets for those that are a little bit different than most hose gaskets. So that kind of gets your question answered. Yeah. I think that's where I would start and see what happens. You know, if you got questions, you got my number there in front of you. Feel free to contact me. Yes, online question.
Yeah, Ron at West Shore, I think you kind of touched on this. On the typical residential equipment, he was asking about the rate of decay. What rate of decay do you look for or rise, and also should the decay level out?
So that's going to depend on what you're doing on a system. Is it new? Is it a new system, or is it a service system? On a new system, you should pretty well see a flat decay. Now, one thing you're going to find out with the core tools, when you cycle these valves, okay, cycle them open or closed, especially when you're closing them from full open, there's a void. If you can zoom in on this a little bit, this is a large ball valve cutaway. There's voids around that ball in there. So when you cycle these valves to part way, it opens up that void around the outside of the ball into the system, and there's going to be a little bit of pressure in that ball if it was open to atmosphere. So when you have a vacuum and you cycle that ball, you're going to see a bump on that vacuum gauge. One way to overcome that is to turn this to about 45 and let it run for 30, 40 seconds to clean out that void and let it get out of there. Then go ahead and fully close the valve, and you won't have that pressure behind the ball anymore, and it's cleaned out at that point. All right. If it's a service system where you have refrigerant in the oil, chances are you're still going to see a little bit of a rise, especially with R410A, because it's very miscible with the POE oil, and it takes a long time to get 100% of that out. Okay, this is one place where triple purging with nitrogen is something I'm not a big fan of, because I think it wastes a lot of time in nitrogen. It doesn't really do much, but I will say that a purge of nitrogen will help with the vacuum reading in a lot of cases, because what it does is it pushes the refrigerant out. It helps to get that refrigerant that's coming out of the oil out of the system, because a lot of vacuum gauges don't necessarily read the same as they're designed on refrigerant, because refrigerant conducts heat differently than air does. And most of your vacuum gauges out there are calibrated to air, because that's what we're trying to pull out of a system. Right? So you're going to see a little bit more of a decay anytime you've got a service system versus a new system.
Back when you was talking about CFM through hoses with and without trader cores, I noticed that your quarter-inch hose has a low-loss fitting. That has to decrease the amount of CFM?
It's going to do it some, but because of the extra restriction in now if I was pulling through a core tool, yeah, it's going to decrease it. But because I've already got that restriction in there with the core itself, it doesn't decrease it much more. It's going to be, maybe a quarter of a tenth less or something like that, but it's right in that same 0.2 area, even with that in there. Yes, thank you very much. JD's got to keep me on track here because I'm not used to having a live audience remote. Anyway, the question was about the 1/4 inch hose where I have this hooked up with a low loss fitting on this particular hose, if that is an extra restriction. So again, it's not much more of a restriction when I have that core in there. If I had the core pulled out and I was trying to go through a core tool, yeah, it would be a bigger restriction. That would be something I would want to remove. Okay, now that pretty much sums up that portion of it. So, more questions. What do you guys want to know? Yes, sir.
How does the app work for
Any of the gauges? So, you download the app. Now, yesterday we just launched a new app. There was the original app called the Ion app, and we've been having some problems with it and hadn't been able to get it updated right, so they built a new app called Appion Central. So it's now on the Play Store as well as the App Store on Apple. And it just went live yesterday, I know, on Apple. But basically what you do is you turn the Bluetooth on here by holding down the Bluetooth button. You jump in the app, you find the devices screen in there, and you pair up by the serial number. You find this in new devices, pair it up, and then it's right there in the app. You can data log with it. You can save it as a PDF and email it, so then you can print it off, yes. The new app is going to have a lot more updates coming. It's because we were having so many problems, they really kind of pushed it out to correct the old app. And the question there was, can you print the data log off? The new app is going to have a lot of updates. They're planning on pushing out an update once a week right now. As they're building new features into it, because I think they brought it out a little quicker than what they really were planning on originally, but they didn't have the functionality on the old app because of some of the updates, especially on the Apple side of things. Yes?
James wants to know from Custom Sheet Metal, what's the best low-cost Micron gauge, in your opinion?
Best low-cost Micron gauge. It depends on your definition of low cost. I would have to say probably the Blue Vac gauge would be my favorite lower cost gauge. I think they make a micro right now.
Okay.
Would be my...
I just have 2 more questions on that.
2 more questions, okay?
Ricardo wants to know, how do you hook a Micron gauge that has 2 ports on it when yours only has 1 port?
You cap one of the ports.
Cap it.
Yeah, cap one of the ports. I'm not a big fan of flow-through Micron gauges because you can't isolate them really well. It's a lot harder. Good question.
And is the Ron wants to know, is the Bluetooth range pretty good on the Appion gauge?
It's pretty decent, yeah. Depends on, of course, environmental, whether you've got metal and buildings and things like that. Line of sight is pretty good. You get metal in buildings, it'll start cutting down. So, anything else, gentlemen?
So on the pumps, I know a lot of guys now with the design like Appion's got, they're starting to copy. They're bragging about being able to change oil on the fly in the middle of a vacuum. Does Appion suggest against that?
Oh no, we advise to do it. Yes, absolutely. So the question was about if you can change oil on the fly with the TES 8 pump, and absolutely. It's a 5-second oil change. You pop the cartridge out, pop a new cartridge in, and while it's running, no problems. Absolutely. Keep it up. Works great. All right.
Perfect.
JD?
Yes, Eric, thank you so much for coming. Guys, give
Thank
him a
you.
round of applause for a great in-depth training. And just so everyone online is aware, and even people here in the audience, what we do is after these trainings wrap, we do keep these, and you can view these on the on-demand section. So if some of your team members couldn't be here, you can go back on the Jackson Systems website and watch this under the Contractor Resources tab for on-demand training. Also, this was a NATE certified training. I did not mention that at the beginning. So please submit your NATE ID there in the chat. And also, I think that recovery tank weight chart
Should be on there as well, yes.
that's under the line cards tab for everybody online. So that is there to download. You can get it now. So again, thank you so much, everyone, for attending online. Thank you guys for coming here tonight. Drive safe, and we'll see you at the next training. Take care.